Hello friends, welcome back. So in the previous videos we have seen that how we can inject dependency to some class. So we have injected the data repository dependency to our data use case class, and for this we have actually created a different module to provide the data repository instance to tell our HILT library that how it should get the instance of this library. So in this way we have created a module and told our HILT library that how it should build a dependency for this, and now we can inject that dependency to any class using this inject annotation, and we are doing a constructor injection over here. So till now we have covered these steps. So in this video we will see that how we can use this data use case class in our view model and how we can inject this to our view model. So the same step lies here also, like we need to define somewhere that how this data use case instance is to be created, so that our dependency injection framework or library can provide this instance to any part or any component where it is required. To do so, we'll have to create another module, you can say. So let's create a different module named let's name it as use case module. So what happened? Yeah, so here we have created a new class. We will actually, this will be object similar to these. So this repository module is having a install in annotation and a module annotation. So similarly this annotation is used over here too, and similarly activity retained component is used as a component because we want that this use case class will be having a life cycle as that of our view model class only. Okay, so similarly we'll use install in annotation over here, and we are going to use activity retained components class, and now the module annotation, and now we'll be using creating the actual object. So now our next step is to define the dependency. For that we need to create a different function which will tell our dependency injection framework that how it should create the dependency, and that function is annotated with @provides annotation. So now we'll create a function, let's say provides use case. Yeah, so now this will return this data use case instance of this data use case. So we will return it over here like this data use case, and now we'll create the instance of this. So it will return data use case, and we know that it will be giving an error because it requires the instance of data repository in the constructor itself. So we already knew that we have created and defined that how this instance will be created, so we can directly use it over here like this data repository, and we can directly provide it to our data use case class. So now what will happen that when we will compile our project, then HILT will build a dependency graph using dagger. Basically HILT will not do anything, it will actually write the code for us that we need to manually do in dagger. Actually dagger is also providing these dependencies automatically, but there are some, you can say, some more code that we need to write, like in this case we can use these components, but in dagger we need to write our custom components, and we need to tell dagger that where it should inject that particular component. So that all of the code is actually you can say that is created at the run at compile time by HILT. Okay, so HILT is not a different dependency injection framework, it is just you can say like it is reducing our effort to write all that code, so it will automatically write that code for us when we'll compile our project. So now what will happen is it will check that from where this data repository instance can be taken. So it will find that this instance can be taken from here, and now it will see that this also requires the instance of API service. So now it will check that from where it can get this instance, so it will find this instance from here. Okay, so now it will check that this requires an instance of retrofit, so it will get that from here. This requires instance of this, so it will get it from here, here. So like this. So this is the dependency graph itself. So every time it builds a dependency graph, and then it will check the dependency, that if this dependency is required, then it will check the graph that what all are what all are the dependencies on which this is dependent, so that it can take all the dependencies from that, you can say, code, or it can build all those dependencies. So this is how actually all the dependencies frameworks work if they are compile time frameworks. So if they are runtime, those are different, so just not get confused. So now what we have done is we have actually created a new module which will provide our use case dependency. Now we'll need to inject this dependency to our view model. To do that, what we need to do is we'll open our view model. So the injection is view model is little different actually. There's just a difference of annotation only, nothing else. Like here we have used inject annotation and we have directly injected the dependency over here. But in case of view models, we will be using a different annotation. So first of all, create empty constructor, and then after a space we'll start typing. So that is view model inject annotation, not just inject annotation. This is a view model inject, a special annotation. This is also provided by HILT, and this is actually a part of the you can say the extension library or the support library that we have used over here. So now the similar step that we need to define constructor over here, and we can provide the dependency of our data use case class, because we have already defined it over here, that how it should create that dependency. So let's go back to our view model and type here like private val and use case. Yeah, so this is the way we can implement, or you can say we can define the dependency. And now the final step is to use this view model in our fragment. So we have already defined here, this is a previous way that how we can use the view model using the view model providers. So but now we don't need such things, because now in our case we are not having a empty constructor, but we are having a parameter in the constructor of view model itself. Sorry for that. So yeah, here. So now to inject view model to our fragment, what we need to do is we'll have to define something that our dependency injection should know, that this is the class where we need to inject something. Okay, so to do that, what we need to do is we need to define an annotation over here. So this is, you can say, like this will tell our dependency injection framework that a dependency is to be injected to our this class basically. So for that we need to define a annotation, that is android entry point. So this annotation will tell dagger that in this class something is to be injected. So similarly our main fragment is also contained by our main activity here, so we'll need to define that over here too. So that is android entry point, yeah, like this. So now what we'll need to do is we will create a new variable over here. So this will always be immutable variable, that is of it is of type which cannot be changed over the future. So immutable variables are which cannot be altered at runtime. So this is so because we don't want to reinitialize our view model anytime in the class. so we need to create single instance, so we'll use val, and then we can give our variable any name, like for ease we'll give it a name of main view model. So now we'll be using an extension function provided by Kotlin. So this function is like this. So by view models, so this one by view models, and we need to define the view model class over here. In our case this is main view model. Okay, so this is giving us some error. So this is giving us some error that inline bytecode is only supported by targeting our JVM to use version 1.8, which we haven't targeted over here. So to do that, simply go to Google, and what you can do is you can search over here Android compile option 1.8. you can do a simple search like this, so you will get answers on your Stack Overflow or anywhere like this. So just copy this compile option. So this is for Java specific projects, but our project is all built in Kotlin, so we need to add one more thing. So just copy it over here and paste it inside your Android block, so like this. And now we'll be using one more thing, so that is Kotlin compile options, so like this. So this is the official documentation. You can copy this from here also, but I have used Stack Overflow. So now this Kotlin option is also necessary, so we'll provide it over here and just click on sync now. So after the synchronization is complete, you will see this error will be gone. Yeah, so you can see over here that the error is gone now. So now what you can do is you can so in this way you have actually initialized your view model without the need to provide any of the parameters to it, because it will automatically pick this you can say the instance of this data use case by searching it over the dependency graph it has created. So it will find it over here, so it will automatically get injected to our view model, and we can use it inside our view model. So this is the way to inject anything to our view model class. So now what we'll do is we will be using this instance of our use case class to actually call the API, or you can say to actually call this this function get repository list, which will indirectly or you can say directly call the API. So let's do that. So just go to your view model. I am closing all the unnecessary files. So now we will be defining a new function. So let's name it as you can say it get repositories list, and now we'll use this you can say instance of our use case class, like here, use case dot, and you can see that we can use this function. So now it will be giving us an error because this was a suspend function. So we can either create a suspend function to call it, or either we can use it inside a coroutine, but we'll not be creating another suspend function because we need to create a coroutine to actually call this function, because now we are in our view model, so we can easily call the coroutine. So we will be using another extension function you can say, or extension property of Kotlin. So that will help us that will actually reduce the code required to create a coroutine. So what we'll be using is we will be using something like this, live data, like this, and here we need to define the return type, okay, or the type of live data. So in our case this will return this type of data, so we'll copy this from here and we can directly paste it over here. Okay, so now we can use the emit function. So emit function will basically we are telling the live data to emit something. Okay, so basically to accept and then give that result. So we'll be using this emit function inside over here. So you can see that we can define this value of type result data that we have defined over here. So we'll be doing a emit, and we know that whenever we'll call this function, the first thing it should return is a type loading, because we know that this get result will be called after that loading, and it will take you can say 1 2 3 or 4 seconds to actually complete. So the first thing should be the load type loading. So to do that, what we can do is we can simply use this result data class. Basically not a data class, it is a sealed class. So if you don't remember, this was a sealed class where we have these states, you can say. So one of the state is loading, which is parameterless state, so we don't need to provide any parameters. So let's define it over here like this, loading. And yeah, so what this will do is this will return this loading state at the very first time, and after that we will be emitting another value. So that will be our this function. Basically will be calling this function over here. So now how will this work? So basically what will happen now is it will call when we'll call this function from our, you can say, fragment. Okay, so when we'll call this function, it will create a coroutine, you can say, and it will the return type of that will be a live data. Okay, so inside the live data we are telling it to emit a result data of type loading. Okay, then we are telling it to emit a type emit anything that is returned from this repository list, but the return type of this function should be this only. Okay, so now if we open this function, we can see over here that here we are managing two states, that is success and failure. So if this API is succeeded successfully, then the result here will never be null. Basically the list of repositories will not be null. So if these are not null or empty, then it means it is success and we are returning it as a type success. And if it is empty or null, then we are returning a type failed with a message something went wrong, please try again. Okay, and finally we are returning this result data. So now when we'll invoke this function, it will return firstly it will emit a type loading, then it will call this function and will wait until this function returns anything. And once it returns, it will either be success or failure. And once this gets the data, it can take up to, like, you for example, let's say 5 seconds. So it will wait for 5 seconds. When it will return the data, it will automatically give us the data basically in our callback, which we'll be implementing over in our fragment. So now this is the way this works. So now one more thing left over here is we need to actually return this live data like this. Okay, so yeah, so we'll be returning this live data as it is. So now we can use this function inside our main fragment. So let's use this ViewModel. So what we are doing here is we will be only using we'll be only calling this function directly in our own activity created, because what we need to do is we need that whenever our application is started, so it should get all it should fetch all the repositories. So let's use this ViewModel instance and call this function. So we know that this function will return a live data, okay, of type this result data. So which so we will define we'll define a variable which will contain the live data returned from this function, and then we can observe over this variable because this is a live data. So in the case of fragments, the first it requires two parameter basically. The first one is the lifecycle owner and second one is the actual observer, which will observe the data changes. So in case of fragments, the lifecycle owner can never be this, because we cannot directly reference to our fragment. So we'll need to provide a view lifecycle owner. So till the view is in the current state of the view itself, that is on created, pause, resume, or stop, or destroyed, anything. So the owner will be view lifecycle owner, and second parameter will be our actual observer. So just control space over here and you can see the observer over here. Just press enter, and when again you will click enter, so here in the suggestion you can see that what type of data it will return. So it will return a data type result data, and the type of the model here is GitHub data model. Okay, so you can again press space enter over here, and here you can see you can use this suggestion like here repositories list, or rather use it a simple name like result data itself. Okay, so now we'll see that how this our previously created sealed class works, how these states are managed. So now in our main fragment what we will do is we will be using when, and here we will provide our returned data, that is result data. So now we'll check that what type of result data we received. So to do that we have a function named, or you can say a keyword name is. So is will in simple terms of it is a simple English statement, you can say that this is this. Okay, so like we are asking it if this is of type whichever we define here. So in our case we will be defining that is result data dot loading. Okay, like this. Or the other thing is so what can be the states? Result data dot success. The third one is result data dot failed, and the last one is, which we haven't used actually, is result result data dot exception. So we haven't handled the exception anywhere in our project right now, but when you will work on production ready apps or anywhere, so you need to manage these exceptions. So now what will happen is, so whenever our result data is returned, so it can be of type loading, okay, or either it can be of type success or failure or exception, whenever you will manage that. So when this result data is returned, it will check if this type is loading or the type is success, failure, or exception. Okay, so you can see that how we are managing the states over here. So these are the states of data, that is in loading state, success, failed, or exception. Okay, so according to these states we can manage our UI or our data. So if the state is loading, so we can create a progress loader over here in our UI, or a dialog or anything to show user that something is loading. So if that is success, we need to get the actual data returned. So in our case it will be returning a data of type this GitHub data model. Okay, and if it is failure, we need to show user some sort of error message or toast. And if it is an exception, we need to also handle that, what should happen, like should it retry, or should we show user a error message or anything in the toast or dialog. So in our case we will be managing these three states. So the first one is loading, second one is success. So let's see that how we can get the actual data when our state is success. To do that, that is a very simple thing. So use this result data inside here like this, and if you remember that we have passed this as a parameter. So the parameter name is, or you can say the variable name is data. So we can directly call this data using this reference of this result data. So just dot data. So you can see that the type of data returned will be GitHub data model, and so you can put it inside another variable, let's say GitHub data model. So now you can directly query over it to get any of the values like this. So what this will this is actually of type list, array list, as you can see over here. So this is of type array list. It will be having a object named this and multiple values inside it. Okay, so you can query anything, but right now we'll be not doing this. We'll be doing the actual UI part in the next video, but currently in this video we will run our application and we'll see that it should actually call the API. Okay, so we'll open our logcat and we'll type here OK HTTP. So what this will do is this will filter all the result. So like if you don't type it, you can see that there are multiple number of results. So if we type OK HTTP over here, it will filter on and show only the results that is from our API. This is because we have actually used the logging interceptor over here. So if you will open your network module, I am just minimizing it for a time. So if you open your network module, you can see that here we have implemented our logging interceptor library. So this is the function of this library, that it will log all the requests. So this is the type, level type is body, so it will log all the requests including the headers, the parameters, the URL, the type of request, the return result from that API. So for this purpose we are using this HTTP, okay, HTTP over here. So it is giving a I think our application has ran and it has given us an error. Yeah, the error is very simple, that we haven't defined the internet permission in our manifest. So we need to define the internet permission over here. I usually miss it every time I create a demo. So just clear the logcat again and rerun your application. So this time you can see that whenever our application main fragment gets started, the API is actually called. This is an exception over here, but as of now you can see it over here that the API actually get called. Okay, so the exception here is, we need to check that what the exception is. So socket exception, I'll have to identify that what this exception can be, because we actually haven't handled the exception in our case, so that's why the application is crashing. But this exception should never come. Okay, so basically this is the URL and the type of request is get. If you open this URL directly in your browser, then you can see that it will list all the repositories. So we should actually get all these repositories rather than this exception. So I'll debug that what's the case of this exception, and in the next video we will be seeing that how we can fix this and how we can actually show the data in the UI itself. So stay tuned. So bye bye, take care.